Hi, I'm Everett. Welcome back to the shop. What we're doing this time is a bit of work I've been wanting to do to the mill for quite a while. Similar to the last video where I put the digital readout on the quill so that I could actually know how far the quill is moving for a change. What we're doing this time is we're taking and mounting up a mist cooling system to the mill itself. That way it can blow the chips away, keep the cutter a little cooler. I'm hoping I can get a little bit more life out of my end mills this way. And the thing is, I didn't want to spend a whole pile of money on it, so I wound up getting a couple cheap bits off of eBay. We make a couple bits out of some scrap I have kicking around. And the most expensive part was actually buying the coolant. But thankfully, one of my buddies in the neighborhood here, who is also a hobby machinist, is willing to go halfers on a jug, because one jug makes about 33 gallons of spray mist, which would last me 10 years. So yeah, we went halfers on the cost, and that made it a lot more affordable. So this is how I did it on my mill. Again, depending on what sort of junk you have kicking around and what sort of ways you want to do it with yours, you may be different, but maybe this sparks some ideas. This is what I needed to do here. Yours may be different. So hope you enjoy it. Another thing I've been wanting to do with this mill is set up some sort of mist cooling system. Quite a while ago, off of eBay, I got one of these things. It's fairly cheap. One downside is, I know it came right out of Southeast or Eastern Asia. It's an 8mm fitting for a push lock type line, basically a plastic line. Well, I started looking around, and it's not as common here. 1/4 inch and 1/2 inch are for air brakes and such, but apparently not 8mm, so we're going to make a fitting. What I'm going to do is, we've got some brass here. We'll make a fitting that actually slides in and seals against the little sealing ring inside. Past that, it's going to thread onto a little shut-off valve, and then an air fitting to go onto the line. So that shouldn't be too big of a deal that way. I'm going to make the bracket to support it so that it actually provides support to that fitting as well. What I've got are, well, a couple pieces of steel that one of the guys at work gave me. As far as I'm concerned, it's nice 1/8 inch steel, and it's here. So there are 2 bolts back here on the 2 bolts that hold this little chip shield, or chip flap, if you will. I want to use those bolt holes. And might come up, or might go flush, I'm not sure yet. But the basic idea is put that, or have one piece there, and then another piece hanging off that direction to be able to support the sprayer mechanism itself. I'll just weld this corner here, not a big deal. But first thing I need to do is figure out what the spacing is on those 2 holes, and drill the 2 holes here. Then we'll cut this to length and weld a piece on. 12mm head, pretty standard for metric equipment, well, Asian metric equipment. Whew. Yeah, someone needs to clean that more often. What I've decided to do is take that flap, and if I take the bar out to flush at the end there, at the end over here, actually that looks pretty darn good, so I'm going to go with that. So I just took a Jiffy marker and circled through the holes there, and so what I'm going to do now is I'm just going to go over to the drill press, poke a couple holes through here, 5/16. What I'm going to do with this one is I'm going to cut it off right where the holes are. That'll be about the right length, because where it's going to sit here, that'll be what I need for supporting the fittings. Drill the pilot holes first. Thankfully, acceptable tolerances for this particular part are basically as long as it fits. There. Just like that. Yep, even with a dull blade, sure beats cutting that by hand. I have a new blade for it. I'm just a little on the cheap side to put one in. Nice. Hopefully at least we can get some cool shots with this one. Need to tack it first. Got it on DC tag, about 130 amps. Just have it sitting on this block here for squaring it up. Tack it. All right. Yeah, definitely shaky. Actually, that one doesn't look too bad. You know, it's such a world of difference between welding steel and welding aluminum. So that one there, I'm actually pretty darn happy with. So that bracket looks like it should fit quite nicely right there. The next step is I have to take the sprayer nozzle, and because of the fact that it's going to be sitting something like that, I think the next step would be wise to mark out the two mounting holes for this block, and then after that we'll make up our jumper piece or our adapter out of the brass and mount our valve. Once I mount the valve, then I'll put some form of bracket back here to support it, and then that way this piece that I make out of the brass cannot come out of that fitting. Now this little unit has to sit something like that, and I'd like to keep this edge butted up just against that edge of this material, more for looks than anything, just sort of better pleasing lines. And something like that I think would work just fine. Metric hole, imperial transfer punch set, it's going to be close but not perfect. There we go, two little pit marks. So what I found in my screw bin were a couple of number 8 32 by 1 inch long screws, and if I use these, well, I'm going to have to because they're about the best I've got at the moment. They come through and they stick out the back just slightly. The best thing to do will be just drill and tap that plate, and we'll just screw the screws straight into the plate. They're number 8 32, therefore I needed a number 29 drill bit for tap drill, and number 8 32 tap. I've seen people just take these straight flute taps and just buzz them right into a hole, but I've always been leery of doing that. Maybe I just had one or two of them too many crack off on me. I put lock washers under the heads just because. Now the piece of material I have that I'm going to make the special custom fitting for in the middle here is just big enough that I will be able to cut an external thread on it, but not really an internal thread. So if we mount that to right about there, then yeah, that's pretty much how long this piece is going to be. Only this piece over here has to actually be, 8 millimeters or 5/16 back, say 3/4 of an inch. In the center here, again, there's going to be a hole all the way through. The barbs inside of here, I don't know if you can see them if I tilt it up. You may be able to see inside there, see those little barbs. They're made to grab into plastic, not really brass. So we're going to have to find some other way of mechanically holding this from sliding back. As far as the length of the little brass adapter, it looks to me if we make it, well, overall length, yeah, if we make it overall length, give or take 2 3/4, 3 inches. Let's go 2 7/8. Yeah, we'll make it overall 2 7/8. I don't have a taper attachment, so we're going to have to use a round die for a 1/4 18 NPT taper, tapered thread. The taper is 3/4 inch per foot, which with the math comes out to roughly 1 3/4 degrees. I've set the compound to that angle. We're just going to skim a little bit to make this a little bit easier to make our threads, and then we're going to put a little chamfer on the front. In its previous life, it had looks like a 1/4 inch hole drilled in the front. We're just going to carry that hole all the way on through to the rest of our part. Light pressure at the tailstock to keep the unit engaged. And considering this is where this is going to have its new happy home, yeah, that'll suffice. Now for the amount of air this has to push through it, a 3/16 hole would be plenty big enough. What we're going to do is we're going to drill through from this side a good chunk of the way. It has to be about 2 7/8 overall length. So we'll drill in about 2 inches from this side, take it out, we'll cut it off, cut it to length, then we're going to make the feature on the other end and do the final drilling after that. That way we're not compromising the strength of the material as we're cutting it by having the inside diameter cut out. We're now drilled about 2 inches inward. There we go. Cut off the length. It's still a little rough over here. Overall length is within a few thousandths of 2 inch 990. So we need to remove 110, 115 thousandths, somewhere in that neighborhood. Bring my dial indicator over on the bed. I'm going to be turning this down to 5/16 of an inch. The thing about this is where it goes into the block with that little press fitting, I took a measurement. It's about 700 thousandths to the bottom of that hole. If I take and make this shoulder, the narrower portion here, if I make that narrower portion roughly 750 thou long, I know it'll fit. It's okay if that narrower tube section is longer, it just can't be shorter. Yeah, 330. let's take a finish pass of 7 thousandths. 7 thousandths on radius, and if I have to polish it down to 315, life goes on. In fact, it may even be preferable. .316. Perfect. Because we are going to polish that into final dimension. That's smooth, which is what we want. Nice. I want this as smooth as possible because it has to seal on an O-ring. A little chamfer on the inside of the hole. You know, I might just snug it into the valve as it sits. Yeah, I'll use the soft jaws and the vise. A little bit of the Teflon tape. Make sure I'm going the right direction for one thing. There we go. That's as tight as she gets. Fitting on the airline. So that, the fellow there, will slide into, slides into there. Come on, you were in there earlier. There we go. I like that. Now, just trying to figure out what I'm going to use for a strap. Let me check the junk bin. I'll be right back. Well, the solution I've chosen may not be pretty, but it's going to work. Baling wire. Well, mechanics wire. I know it hasn't really been used for baling for, what, decades, but we're going to go up. This is more of a paranoia and safety factor. Murphy repellent, if you will. You know, one of these days I'm probably going to have somebody write in whose last name is Murphy, and they're going to be right choked at me for making jokes about Murphy. That is not going anywhere. As I say, it may not be the prettiest, but that's not going anywhere. That'll work. Finally can put this whole thing together. I'd like to try this before I go to bed tonight. Anybody care to guess how old this wrench is? Toyota motor, a 10 and a 12. I pick up wrenches at garage sales and tool sales and whatever. I just thought it was really cool. It's got a 10 and a 12, so it stays with the lathe. It's very handy that way. I like that. Yeah, it's got a little bit of flex. At some point, if I decide to, I can always add another brace in the back, but for now this is good. Stick our straw in the bottom. There. Install the anti-shrapnel device. And I can hide back here. I need to clean up the edges of this 1-inch steel plate for a project that it's upcoming. So the edges need to be squared off anyway. So this seems like as good a time as any to test it out. Well, that looks like it's saw cut, but I have 2 flame cut edges, and this side here was done with a bandsaw just the other day. So let's use that side as our starting side. You know, I know a number of you guys have all had flood coolant or spray coolant or whatever for a while. This is awesome. I got digital DRO on the quill, and I have mist coolant. This is awesome. I was having issues before with chips getting caught back underneath and causing issues with recutting. This gives a much better surface finish. Hopefully I don't burn out end mills either as fast. Considering the fact that this is actually an old end mill, the flood coolant I know has added a better surface finish because I used to get more scratching with recutting of chips. So yeah, I am actually quite happy with that. Right on. So yeah, I'm pretty excited. That's gonna make milling things a lot nicer now, being able to run coolant and to blow the chips away. I know that some of you have had mist coolant or flood coolant for quite a while and it's just normal for you. This is totally cool. This is new for me. Anyway, thanks very much for watching. Thanks for subscribing. See y'all next time.